All right, mathematicians, we're going to solve inequalities with just one variable. So here we've got kind of a complex inequality, but we can get rid of the parentheses by distributing the negative 3. So negative 3 times 6x will be negative 18x. Negative 3 times 2 is negative 6. Now we'll see some like terms that we can combine on that left side of the inequality. If you want to use the commutative property of addition here, you can switch this order and put the plus 4x in front of the minus 6. Now that minus needs to stay with the 6. Now we can combine these like terms. That negative 18x plus 4x is negative 14x. Still have that minus 6. Now we got a two-step inequality. To get rid of the minus 6, we'll add 6 to each side. 22 plus 6 gives us 28. So we have negative 14x is less than or equal to 28. To get rid of multiplying by a negative 14, we could divide by a negative 14. And so we get x, and we have a negative 2 over here. Now, we will need to reverse the inequality symbol. You may not have seen this before, but let's just think about another way to solve this and see if it makes sense. So if we take that negative 14x less than or equal to 28, and instead of dividing by a negative 14, what if we added 14x to each side? Well, we'd have nothing on one side, and now we have a positive 14x being added to the 28. And then from here we could subtract 28. So this is getting the variable term by itself, but where it's a positive coefficient. And then we could divide by positive 14. And so notice what we end up with. Negative 2 is less than or equal to x. Well, that means the same as x is greater than or equal to negative 2. So if you multiply or divide both sides of an inequality by a negative number, you need to reverse your inequality symbol. If it's less than or equal to, you change it to greater than or equal to. If it's less than, you change it to greater than. If it's greater than, you change it to less than. If it's greater than or equal to, you change it to less than or equal to. And then that would allow you to skip all of these steps that we just did out to the right. So don't forget, if you multiply or divide both sides of an inequality by a negative, you have to reverse your inequality symbol. Now to graph this, we're trying to plot on a number line all of the solutions, the x values that are greater than or equal to negative 2. So think about where negative 2 is, right between negative 3 and negative 1. So we want to include the negative 2. So we're going to put a colored in point at negative 2. And then we're going to select all the ones that are greater than. Well, greater than on a number line is to the right. Also notice that the greater than symbol points to the right, just kind of like an arrow. So this is our solution. X is greater than or equal to negative 2, and the graph of that solution. This time we've got some decimals. We've got variables on both sides, so let's get those variable terms together on one side. So subtract 2.2x from each side. We get 2x plus 13 is less than negative 5. And then to get rid of the plus 13, we'll subtract 13. At this point, we're at a two-step inequality. So we have 2x is less than negative 18. And then to get rid of multiplying by 2, divide by 2, and we get x is less than negative 9. Notice that we did not reverse the inequality symbol. Well, why is that? Well, we just divided both sides by 2. We did not divide by a negative. If you multiply or divide both sides by a negative, that's when you reverse your inequality symbol. Now let's think about the graph of this. Negative 9 would be right there between negative 10 and negative 8. This time we want to emphasize the fact that we are not including negative 9. Negative 9 is not less than negative 9. But we do want to include anything to the left of that negative 9. So like negative 9.1 would be included. Negative 10, negative a million. All of those values to the left of the negative 9 would be in your solution set. Number 3, we can distribute the negative 3, and we get negative 6x minus 21 is greater than negative 6x minus 4. We've got variables on both sides, so let's add 6x. That gets the variable terms together on one side. Well, negative 6x plus positive 6x is 0. It goes away. So we have negative 21 is greater than negative 4. Think about where those are on a number line. Negative 21 is to the left of negative 4, so that is a false statement. Negative 21 is not greater than negative 4. So this ends up with no solution. Sometimes we'll write it as the empty set symbol. If you think about all your solutions to this problem, to this equation, or inequality, there are none. So no solution is our final answer. If we did a graph of that, we just have an empty graph. There are no points that work, no x values that work in this inequality. All right, this time we have a little distributing on the right side. We'll get 14x plus 63. Want to get those variables terms together, so subtract 14x from each side. 3 is less than or equal to 63. Well, that's true. So what this means is if you look at a graph of this, and you could put any values, it really doesn't matter. So we could say maybe just starting at 0, negative 1, and positive 1, and so on. Any value works. 3 is always less than or equal to 63. And so we would just shade in the whole graph. In words, we could say this is all real numbers. Any real number that we put into this inequality works. We can illustrate this just by picking some kind of different real numbers. Let's suppose we try x is equal to 10. Well, we'd have 14 times 10 plus 3 is less than or equal to 7 times 2 times 10 plus 9. Just use your order of operations on each side to simplify this. We'll multiply before we add. So 14 times 10 gives us 140. 140 plus 3 is 143. 2 times 10 is 20. 20 plus 9 would be 29. And then 29 times 7 would be 7 times 9 is 63, carrying a 6. 7 times 2 is 14, plus the 6, 203. That's a true statement. So that's a solution to the inequality. We could try maybe negative 5. So 14 times negative 5 plus 3 less than or equal to 2 times negative 5 plus 9. All right, using order of operations, 14 times negative 5 is negative 70. Plus 3, if I go ahead and do that, negative 67. On the right side, we'll multiply first. 2 times negative 5 is negative 10. Negative 10 plus 9 is negative 1. 7 times negative 1 is negative 7. So a negative 67 is less than or equal to the left of negative 7. So again, that's a true statement. You could try any values you want, and it will work in this inequality. So we have all real numbers. All right, we've got two different t-shirt companies, and we're told to figure out how many shirts must be ordered by T-Shirts for All for it to be less expensive than T-Shirts Express. So let's put the expression for T-Shirts for All on the left side, since that's the one we're kind of trying to find the value that works for to make that less expensive. Okay, so $60 design fee. So that's going to be a one-time fee for the t-shirts, and then 11 times the number of t-shirts. So I'm going to let X represent the number of t-shirts. All right, so we're trying to figure out when is that less expensive than the other company's cost. So the other company charges $13 for each t-shirt. So if X is the number of t-shirts, 13 times X, plus a one-time fee of $40. So we're going to solve this for X. All right, so we want to get the variable terms together on one side. We can subtract 13x from each side. Actually, I'll do it a different way just to kind of illustrate something. You might think to keep those variable terms positive. Well, we'll have 60 is less than 2x plus 40. Then you can subtract 40 from each side, and we get 20 is less than 2x. To get rid of multiplying by 2, divide by 2, and we get 10 is less than x. So if 10 is less than x, then that means x is greater than 10. So the solution here, the number of t-shirts that must be ordered, has to be greater than 10. Well, you're only going to order whole t-shirts. It doesn't make sense for it to be a decimal or a fraction value or a mixed number value. So we could say that how many t-shirts must be ordered? So you must order more than 10 t-shirts. Or 10 shirts for t-shirts for all to be cheaper. Now this is an equivalent answer to this. Another answer that would make the same sense, make just as much sense, is to say 11 t-shirts or more. So you could either say more than 10, or you could say 11 or more. So an alternate answer here is to say 11 or more. All right, so hopefully this helps you with solving inequalities. Just a reminder, when you multiply or divide both sides of an inequality by a negative, reverse the inequality symbol. Also, what we saw in the end of this one, based on the way I solved it this time, we got the variable term by itself on the right side. You do want to go ahead and flip that around and see it with the variable term on the left side for your final answers. All right, so hopefully this is helpful.